Hey everybody, welcome back. And in this section, we are going to talk about Azure Virtual Machine traffic flow. In my previous section, we talked about a NIC which can be attached to virtual machine, and it just cannot be one NIC. You have option to attach multiple NICs, and then you are going to give the IP addresses. These IP addresses are going to be private in nature. However, if you want to reach out to the internet, you need to do some internet working and you must have understanding on routing, how the routing works here. Azure automatically creates system routes and assign those routes to each subnets in the virtual network. You cannot create system routes nor you can remove system routes, but you can always override some system routes with custom routes. Azure creates default system routes for each subnet, and you can see on my screen these are the default routes. Each route contains an address prefix and its next hop type. Whenever a virtual network is created, Azure automatically creates the following default system routes for each subnet within the virtual network. So virtual network, which is next hop type, let's understand what it means. Routes traffic between address ranges within the address space of virtual network. Azure creates a route with an address prefix that correspond to each address range defined within the address space of virtual network. If the virtual network address space has multiple address ranges defined, Azure creates an individual route for each address range. Azure automatically routes traffic between subnets using the routes created for each address range. You do not need to define gateways for Azure to route traffic between multiple subnets. Though a virtual network contains subnet and each subnet has defined address range, Azure doesn't create default route for subnet address ranges. This is because each subnet address range is within the address range of address space of virtual network. If you have previously worked on any router or maybe on switches, the way the lookup happens, it is exactly the same way the routing lookup happens here. You might have multiple subnets called from the bigger range, which is a container range. So here you are going to see a container range. It means all the subnets falls within the same container range can talk to each other. The next type is going to be the internet that routes traffic specified by address prefix to internet. The system default route specifies 0.0.0.0/0 address prefix. If you don't override Azure's default route, Azure routes traffic to any address not specified by an address range within the virtual network to the internet, with one exception. If the destination address for one the Azure services, Azure routes traffic directly to the service over Azure backbone network rather than routing traffic to the internet. Traffic between Azure services doesn't traverse the internet, regardless of which Azure region the Azure virtual network exists, or which Azure region and infrastructure instance of Azure services is deployed in. You can override Azure default system route for 00.0/0 address prefix with custom route, which is going to be the UDR. And we will discuss that UDR in next section. Then the third option is none. Traffic routed to none next hop type is dropped rather than routed outside the subnet. Azure automatically creates default routes for following address prefix, where those belongs to RFC 1980. So 10.0.0/8 172.16.0.0/12 and 192.168.0.0/16. System routes, optional default routes. Virtual network VNet peering. We talked about, we created VNet peering earlier, and whenever you created VNet peering between two virtual networks, a route is injected for each address space within the address space of each virtual network a peering is created for. That is how both the VNets they communicate to each other. And we have not added any separate routing for that. The next is going to be the virtual network gateway. One or more routes with virtual network gateway listed as next hop type are added when a virtual network gateway is added to virtual network. The source is also virtual network gateway, which we can see here. Because the gateway adds the route to the subnet. If your on-premises network gateway exchange BGP routes with virtual network gateway, a route is added for each route propagated from the on-prem network. It is recommended that you summarize on-prem route to larger address space so that fewest number of routes will be propagated to Azure Virtual Network Gateway. The third type is going to be virtual network service endpoints. A public IP addresses for certain services are added to route table by Azure when you enable service endpoint to the service. Service endpoints are enabled for individual subnets within the virtual network so that a route is only added to the route table of subnet as a service endpoint is enabled for. The public IP address of Azure service change periodically. Azure manages the address in the route table automatically when the address getting changed. Apart from system routes which you cannot delete or modify, but there's an option with the custom routes which is sometimes called user defined routes. You can override system default routes. So you can create virtual appliance. These virtual appliance, for example, it can be a firewall which is sitting somewhere in the VNet. It can be the SD-WAN devices to route the traffic over the WAN network. And you can create a specific routes towards those virtual appliance. Next option, if you have some sort of the on-prem connectivity and you are using the virtual network gateway, you can override the traffic pattern while putting a route towards the virtual network gateway. Then you have an option to none. Specify when you want to drop a specific traffic for a particular address prefix. Similarly, internet, specify when you want to explicitly route traffic distance to an address prefix to the internet, or if you want traffic distance for Azure services with public IP addresses kept within the Azure backbone network. Now let's take a look on this diagram and discuss about the traffic flow. You might have multiple scenarios. Maybe your resources are behind the load balancer and any request which is coming from outside in this direction, it will be going outside from here, and the IP will be used, which is going to be the public IP assigned to the load balancer instance. Similarly, you can have a instance level public IP address assigned. In that case, anything which is initiated from outside will be coming to the public IP address, and while going outside you will be utilizing the same public IP address. The third scenario, you might not have a interface level pip assigned. In that case, if you want to go outside and connect to the internet, you will need to utilize the NAT gateway. And this NAT gateway can have multiple public IP addresses, and it can have the IP prefix as well. So while going out, you will use these pip addresses, which is public IP addresses basically. And you cannot directly initiate a connection towards these VMs. So it is going to be the kind of the NAT device, what you see. Thank you for watching, and I will see you in the next section.